So welcome to the Introduction to Earth Engine Python edition. I'm Tyler Erickson, this is Kayla, and we are going to be your co-instructors for this session. There's also a few TAs that are here in the audience. Tony is here, I see. And Kel and Justin are in the back, so please raise your hand if you need help at any time, especially when we get to the hands-on session. Let's see, the first thing I do want to do as a preliminary though is is there anybody who hasn't signed up to run Earth Engine, basically, gone to signup.earthengine.google.com? Because we can help you with that if you haven't done it already. But, oh, there's one? Okay, so.
There's three, yeah.
Oh, three? I didn't see the other ones because the lights are kind of bright here. So if we can get TAs to help you sign up and register whatever account you need with Earth Engine, that will help us out when we get to the hands-on section. Yep. All right. So we're gonna be passing off the presentation and the hands-on session between Kayla and myself. But I'm going to start here with an introduction basically to why we think you should be here. And as Michael said earlier when he was giving an introduction to all the talks, if you are a very beginner to Earth Engine and wanted to learn about some of the concepts of it, this may not be the best course because we have to spend a lot of more time, I guess, on the setup of the environment. But if you're coming in as an experienced Python user, or you already have experience with Earth Engine going through an introductory class using JavaScript, then this is probably an appropriate course for you. So here's the agenda that we're going to go through. We're going to try to get hands-on after about 30 minutes into this session, and then we will do 30 minutes hands-on this hour. We'll have a break, and then in the second hour we'll start with hands-on and then go to a little bit of slides of the wrap-up at the end. All right, so I want to start off with some reasons of why you might be here to do Python and Jupyter. I love Python. I'm a programmer. My background is working in Python, even though in Earth Engine I do use the JavaScript code editor quite a bit of the time. But it's important to understand that underneath the hood of Earth Engine, it doesn't know anything about Python. It doesn't know anything about JavaScript. We have servers at Google that are running Earth Engine on the back end. Most of it is written in Java, although you don't need to know that. And there is a REST API that sits in front of it, which is the main way that you will submit questions to Earth Engine. And so everything has to go through that REST API. But to make things easier, especially if you're constructing really complex analyses, manipulating all kinds of geospatial data that Earth Engine has available, you're probably going to want to use the JavaScript or Python client library rather than coding directly against the web REST API. These are the two client libraries that we maintain at Google, but there are other people that have created even other client libraries for other languages to make Earth Engine useful. But I'm only going to point at these two because these are the ones that we support by the Earth Engine team. There's a lot of stuff that you can do with these client libraries. You can access them through a command line shell, which is OK if you're doing something that doesn't involve a lot of interpretation of the graphical data, if you're trying to automate something. You can also build web applications on top of them that can speak directly to these client libraries. But that is usually after you've already come up with an algorithm that you have figured out how to code into Earth Engine, and you want to share it with others around the world. When you're developing an algorithm, one of the best ways to do this is to go into the code editor because it's an environment that we have created and designed specifically to be able to do the things you mostly want to do when you're designing an algorithm. It's kind of, we've designed it for scientists developing geospatial algorithms. So there is a lot of features that are available in the code editor that make this journey easier. One of the key ones is authentication. You can just log in and get going right away. But we know that a lot of people don't necessarily like to use JavaScript as their primary preferred language. Actually, as a show of hands here, how many people would say they are stronger as a JavaScript programmer than a Python programmer? How about you're stronger as some other language other than Python as your preferred, or as Python? OK, so we got at least some other ones that are not JavaScript or Python within there. Python, it is accessible to a lot of people. It's used at a lot of universities. It's easy to read and has a lot of advantages, so people tend to use it. But if you're developing, especially something that deals with spatial data, it's helpful to have some graphical user environment in order to develop your algorithms. And for this, we often pair the Python client libraries with Jupyter. And there's various Jupyter IDEs we'll be going over today. So what is Jupyter? Kind of at a high level, it's a project that focuses on open standards for what's known as interactive computing. So you can actually encode a description of your algorithm along with the code that's running itself. So it's very useful for explaining concepts, teaching, communicating things that are really complex. And it's great for some of the geospatial analyses that we do with satellite data, which tend to be quite complex. But the Jupyter project just put together these notebook formats, protocols, and the kernels, which is the coding language that is running behind a notebook that works in Python and other languages as well. They have standardized this, and then there have been a lot of implementations that follow those standards. Jupyter Notebook is the standard one that is developed by the Jupyter project that you can download. It's an open source tool, install on your own machine. But there are other ones like Collaboratory that we'll be using today, which is a Google implementation of those standards that were put forth at the Jupyter project. I'm just going to say that there's a lot of them out there. I only listed like 5 examples right now, but there's all kinds of different notebook environments that you can work in. The notebook itself it consists of both cells that you can describe what you're doing and code to actually run. So it's kind of like a live coding environment. Kayla is going to spend a lot more time going through the features of what you can do in Colab and in Jupyter environment. All right, to give a quick kind of comparison of like why you might want to be using Python and Jupyter as opposed to JavaScript in the code editor, I'm going to start with the JavaScript in code editor. And for this, it's very easy to get started. I mean, we've designed it to be easy to log into. It has the documentation in there. It has the standard way that you're probably going to get back results, like a map result at the bottom. It's really set up for a lot of the geospatial environments. As I said, it has built-in authentication. One of the great features of the code editor is you can just say get link. It gives you a URL, and you can put that on Twitter. You can send it to your collaborators or something, and they get a snapshot of exactly what you were looking at and how your algorithm was laid out. So it makes it very easy to reproduce somebody else's work in your own environment by just sharing these links. We have lots of examples in the Earth Engine documentation. Most of them are centered on the code editor because, once again, because it's very reproducible, everybody can see the exact same code and get the same results as you do. But one of the downsides I would say is that because we've tried to standardize it all and give a good experience for the use case that most people want to have, there's a little, I would say, limited customization of what you can actually do in the code editor. Some of the people in the community, the Earth Engine community, have been proving me wrong and customizing the code editor in very creative ways, but it's not, I would say it's not really designed to be extensible in that way. From the other side, for the Python and Jupyter, the Python and Jupyter environment allows for intermixing, once again, the description and the code, so you can actually have a multi-step process that's very easy to understand if it's laid out correctly. You can do a series of steps. It's not just run and the entire thing goes. It can be like hundreds of steps or dozens of steps, and we'll see that today. And it's easy to share your code using more standard technologies on the web for sharing code in general. Like Python package index, or you can put your code on GitHub and import it from there directly. There's many, many different visualization options that are within the Python ecosystem that we'll see a little bit of today, but there's a lot more that we are not going to be able to show you because of the time. And Python is a glue language that allows you to connect to many other services. So we often use it to talk to other Google Cloud services and integrate a lot of things together with Earth Engine. And as I said before, it's very customizable. That can be a little confusing when you start off, but it's actually very flexible if you're using it long term. But on the downside, there is assembly that is required. And it keeps getting simpler year after year when I teach this, but there's a little bit of like stuff that we're going to have to configure in order to get it working. And then related to that, because it's customizable, you have to realize that when you customize your environment, it's going to be harder for somebody else to reproduce it. So you're going to have to work extra hard to get help on some of the work that you do if you're working in the Python land. All right, with that, I'm going to turn it over to Kayla to talk a little bit more about a particular environment, Colab.
Hello, everyone. So as Tyler was just mentioning, the benefits of using Python in Jupyter. So now I'm going to introduce Google Colab, because it's an easy to get started Jupyter notebook, and that is what we're going to use today in this workshop. We're using it because it's really easy, like I said, to get started. There's easy integrations with Google Drive and GitHub. Earth Engine comes automatically installed, so that makes it really easy for us to use it here today. And it has access to free resources. So who's ready to get started with Colab? Woo! Okay. So I want you to all open your computers if you haven't already and click on this Colab 101 link.
Actually, let's go back to, I should have pointed this out on the very first slide that we had. There is a link to this talk.
Oh yeah, sorry.
Right.
So sorry guys.
Or if you go just to the Geo for Good agenda and search for this session, it's basically the link in the resources is going to get you into this presentation.
So
if anybody's having problems with that, just raise your hand, please.
Just give it a couple of seconds. All right.
So anybody need help at the moment getting in there? Please raise your hand and the TAs will come and help you get in there. Yeah, just keep your hand up until they get all the way up to you. There's somebody up in the front, Justin, as well.
Slide and you put a scroll into the agenda.
If you wait, it should go scroll down for you there. If you pause a few seconds, it should. Yep.
No access to Drive. How do we access the notebook? Because it's a Drive link. Can we put it as like a gist or something?
It's a.
That's a good question, actually.
I've done it where you can do a gist and then share that link.
So you're trying to get to the presentation right now, or you're trying to get to the Colab?
To the Colab notebook, but if you don't have access to Drive, the notebook won't open up.
Oh, that is. Yeah, I don't think there's a way that we can. Yeah, Kayla, if you go and copy it into a gist, then, as you said, you can get them unblocked there. Thanks. Okay. All right, so something that came up is some people do not necessarily have access to Google Drive. Your organization may have configured it in a certain way that might not give you access. So Kel is going to spend a few minutes giving you an alternative of how to get the same code. I think it's good.
Yeah, that's good. So can you raise your hand if you've gotten access to, you're looking at this page? So a good chunk of people. All right, so the goal of this Colab that I am showing you right now is it's nothing to do with Earth Engine. It's just to get familiar with Colab. And so looking at this, the first step you want to do is you can see my mouse, go and press connect. That allows you to have access to the Colab resources. It takes a...
Might want to increase size on that.
Okay, sorry, 1 second. How is that for everyone for size? Okay, so has everyone connected? Do you have a green check mark here? Okay, so as Tyler mentioned, there's a thing called cells in Colab. So you can have a text cell like this getting started with Colab text cell, and if you double click on it, you can see that there's a lot of rich text you can add images, it's very flexible. And then there is also code cells, which is what I put right here. I just defined a very simple variable in Python, the number of seconds in the day, and then if you write out that variable, it will print it out for you. So in order to run code in Colab, you can hover over and see this play button, or if you want a shortcut, you can use Command Enter or Control Enter. So I'm going to click Run, and this is a warning that comes up and asks you if you trust the code that we're giving you. I think we should say yes. So
Kayla does work for Google.
yeah. Anyways, so we're gonna say yes. And wow, we know the number of seconds in a day. We've learned so much already. So then I wanted to show you guys that if you define a variable or code above in the code cells, so like this seconds per day variable, you can use it in future code cells. So this code cell below, I have the number of seconds in a week. So I'm just multiplying the number of seconds in a day by 7, and you can run that, and it works. So now I'm going to show you some more Colab features. So when you're first getting started, I don't know about you guys, but when I first start with coding, I look for code to copy and paste. That's always a great place to start. So with Colab, those are called code snippets. So if you go to the bottom left corner, there's like these arrows right here, and you click on it. These are a whole bunch of code snippets that you have access to easily copy and paste. So I am going to show you one code snippet. We're going to type in visualization, and I'm going to click on this just randomly. It's a bar plot in Altair. I'll get into what Altair is in a second, but I just want to show you can click on any of these, you can search, and then when you click on one, it has like a brief description about what it is right down here, and then you can insert it really easily into your Colab. So maybe you want to know where we insert it, so if you click like here or something, and then you press insert, now we magically have code in our Colab. And if you inserted the code in a different place, you can easily move the code by using these arrows. How is it going? Is everyone cool? So I chose Altair because Tyler mentioned that there's a lot of fun visualization options in Python, and Altair is a great plotting library. So let's see what this bar plot is. You guys should press run so you can see. All right. Oh. So it's random. It has nothing to do with this talk, but if you're interested, it shows the mean miles per gallon for different cars in different countries. Okay, so now we're going to move on. So what if we get an error in Colab? Right here, I wrote alt.color. Uh-oh, it's an error. So when you get an error, there will be a red squiggly, and you can hover over your mouse over it, and it might tell you more information about it. So if this happens to you today, where you run something and you get an error, or in the future, you can look at that. Another useful thing to know is you can use tab completion for object methods. So if I type in alt, which is the Altair library, and then I type in chart, then we get some methods that we can easily use. And if we don't know what a method is and we want to get help, you can use this help method, and it will give you more information about it. But if you're lazy and you don't want to use the help method, you can just take your cursor and hover over different things. And normally there's information. So for a chart, I don't know why it doesn't want to do it. Oh, yeah. Then you get a whole bunch of information about what is this chart object. And below here, I put some additional resources. So there's an overview of extra features if you want to learn more about Colab. And then there's also a guide to Markdown if you want to learn more about that for the text cells. And then there's a link for Jupyter if you want to learn more about the Jupyter project. How are we feeling right now? Awesome. Are we excited about Colab? Love the enthusiasm. All right, so now I'm going to pass it over to Tyler, and we're going to have
Thanks.
even more fun.
Yeah. All right. I'm going to check in with Kel, see how he is of getting. Did that work? Okay. Okay. Yep. We'll put that in so we'll have them in the future. Thanks. All right. So that was a quick introduction to Colab. There's a lot of other features out there. We'll see some of them as we're going through, and there's a lot of also tutorials that are Colab specifics that will give you ideas of what else Colab could do. But that's enough to get us started for understanding how we can work with Earth Engine in Colab. All right, so if you go back to the presentation, we have a link to a second notebook, this EE, Earth Engine in Python 101. And that should open up a second notebook that looks like this. At the top, we're just saying, hey, this is code that we are openly licensing, so feel free to copy and use it however you want that matches the license, which is the open Apache 2 license. But then it's going to start down here with basically some setup of the notebook that we're going to run through in order to get it prepared and ready to run Earth Engine. So this notebook is set out largely mirroring the JavaScript tutorial that we have in the Earth Engine documentation. It's not quite the same. There's some variations because of the differences in Python and the tools within there. And we definitely were not as verbose and descriptive of like all the different sections of what's going on. But it follows along the same pattern. But one thing that is unique to running in Python is we do have to do that little assembly required, a little bit of setup here. And so the first section here is called authentication. And I set up a code cell here that should work for most people. And we will see how many it does work for. It depends kind of on how your organization has configured and potentially constrained the account that you are using. So we will debug that if you have problems running this, we will debug it as we go along. I'm going to go through this live, but also realize if you switch back to the presentation, there's a lot of like step-by-step in a lot of detail, exactly what you will see on each step of the authentication as you're going through here. But I encourage you just to follow along with what I'm doing right here. So once again, we get a little warning that this was not authored by Google. It was actually myself that was authoring this notebook, but I'm using a test account here to author it. And I'm going to acknowledge that I'm going to want to run that anyway. So we're going to wait for a little bit to see the output of the cell come back. And what it is going to give us is a link that we can open up by clicking on it. So that will be our next step in authentication. So don't get rid of this tab. We're going to be coming back to it later. But to start off with, I'm going to click and make that a lot larger so we can see it. And it's going to bring up this web page, which is our notebook authenticator for Earth Engine. And there's a bit of information that is very important in here. Is like, are you using the correct account, the active account that you want to use? So make sure that this is your Earth Engine enabled account that you normally have. If you might be logged in your machine with multiple accounts, so make sure that is the correct one. You might have to switch it there. And then crucially underneath it, there should be listed a cloud project. And you can select a different project by going in here and going under the drop-down if you have multiple cloud projects that you've set up before. But it's key to note that it needs to be an Earth Engine-enabled cloud project that you are using when you do this authentication in order for this to work. So I'm going to stop right there because I bet there might be 1 or 2 people that actually don't have an enabled cloud project. And if you do not, please raise your hand so that we can get some help to come around and help you try to create one. All right, so keep your hands up. The TAs will be dispersing around here, and we will see how it works. There's enough of, all right, there's 2 in this row here. All right, I am actually going to jump down and help just to move this along for a minute. Can you turn me off? Trying to get a Earth Engine enabled cloud project. Must accept the cloud terms of service. It's an easy click to that page to acknowledge that you're creating a cloud project. Yep. All right, who needs more time to create a Earth Engine enabled cloud project? All right, I'm going to step back up here then. I will select my Earth Engine enabled cloud project. And then hit select to dismiss that dialog page. And now that you have the account you want to use and the project, cloud project that you want to use, you could click the use read-only scopes if you want to restrict what this notebook can do. but we're going to export something later on in the tutorial, so I'm actually not going to click the read-only scopes. And then finally, I'm going to generate a token down here. And it's actually interesting to read what goes on underneath here. It explains what you're granting. It's saying this creates a web application definition controlled by your project provided above. After you click generate token, Google asks for your permission to grant the application access. So you're going to grant permissions to something that you are creating yourself. So that's fairly safe to do. All right. When I hit generate token, I will come to a choose your account page. Who needs more time there? All right, we're doing good. There's a lot of steps here, but if you do them all quickly, it takes like 30 seconds to do. I'm going to select that test account. It will then give me a warning about Google hasn't verified this app that I just created, which makes sense, but I'm going to continue to use the app that I just created. And then finally, it comes, or I shouldn't say finally, the next step is that it comes to a page that asks you very specifically what permissions you're going to grant to this application. And we want to allow it to view and manage our Earth Engine data, which is the first one, and then also manage data and permissions that are stored in Google Cloud Storage. Because we export from there, we often import data from cloud storage. So those are the two permissions that we're going to grant. So I'll go to the bottom and click continue. And then gives you, once again, another warning. Make sure you trust this thing that you just created, which is OK. The reason there's all these different layers of that, that you need to be careful when you're granting permissions to an application because it could do stuff with your data. So that's why there are all these checks and balances in describing exactly what you're granting in a lot of detail. But what is key on this page is a code that is generated and a little copy button next to it. So go to find the authorization code and copy it. We're going to paste it on another page. Anybody need more time right now with this, or we're good? If you raise your hand, if you need somebody to come and help you, we're good. All right. So I'm going to copy that. I'm actually going to dismiss the page I was on so you can see where I'm pasting it, which is back in that Earth Engine 101 notebook. So you paste it into that box and then critically press return. So it actually knows that it needs to accept it. And this is what we're hoping for. Successfully initialized. This is just one way to authenticate. Once again, there's a lot of flexibility around. I would refer you back to the Earth Engine documentation. Look out at Python authentication if you want to know all details about the other options. But this is kind of the easiest way to authenticate from within a notebook. Lots of steps, but it will get you authenticated within here. So I see that most people are looking like they're done. There's a lot of discussion with the TA here, so they're probably working through that. But does anybody else need help? All right, we're authenticated in the notebook. Good thing it's one notebook. We only have to do that once. And the other thing that I did is I wrote, so if you run this cell again and come back here, it basically just checks that you're already authenticated and doesn't take you through that flow again. All right, so we're good. All right, so that is the first part of our setup. The next one is that in a notebook, and often in Python in general, the standard set of libraries that Python has is not necessarily going to be sufficient for everything you want to do. And we, in particular, are going to want to install something called the Earth Engine Jupyter library, which is going to enable some different features in this notebook. And so there is a code block down here that tries to import Earth Engine Jupyter. If it's not found, it branches down here and starts doing a Python install so that it's going to upload it into your Colab kernel. It's going to make that library available. So that's what it's doing. Once it's installed, it's going to tell you which version it is. This is a very new library that I wrote over the past month, and so we're on a very low number at this point. We're running with scissors, but it's very useful. So, all right, everybody good here? The next cell that we have here is going to import all kinds of other Python packages that we're going to use along the way. Some of them are from that Earth Engine Jupyter, or EE Jupyter that we just installed into the Colab virtual machine. Other ones are Jupyter display libraries. I'm not going to go through them in detail, but you can like find all of these by Googling usually the name of it and then Python or Jupyter after it. And you'll find all kinds of information on the web of what these are about. All right, so now we have, oops, I need to run that actually. So now all those libraries are going to be available in my notebook. And now we're going to start actually working with Earth Engine. We've done our setup. We're going to do, let me make that a little larger, not too bad, but. We're going to start off by referencing an image object, an Earth Engine image object, which is a digital elevation model collected by the SRTM satellite. And we're going to assign that to a variable called DEM. So I'm going to run that right here. I should say as I'm going along here, you can see how far I'm through the notebook over in this table of contents on the left-hand side. If you need room, feel free to just click on the table of contents again and it will disappear off to the side, so it'll give you a little bit more real estate. But when I can, I'm going to keep that open just so everybody can be aware of how far along we are. And if you want to jump around in the notebook, you can use that table of contents to basically click and it will take you to the particular part of the notebook as well. All right, so we have run to have a DEM object, an Earth Engine DE object, and so we're going to print out to see what is inside there. And what we have is a really long printout, kind of, it's formatted somewhat nicely, but also is somewhat verbose. But just telling you everything about this Earth Engine image, what bands it has, details of the projection of the bands, what are the properties within here. This is a long description for this image object, and this is one of the shorter ones we have in Earth Engine. When you start getting into like the Landsat data, they're really extensive. Like a massive amount of information is contained within that object. All right, so that's kind of useful. I mean, we got something and we could read about it, but most of the time to work with the data, you're going to want to display it on the map. So the next section here is going to be displaying that object on our first map. And in order to do that, we are going to define some location, the longitude and latitude on Earth that we're going to center our map on. And then we're going to build some initialization parameters, defining what is the center of our map and what is the zoom level here. And there's a little bit of Python manipulation in here of reversing the list of the long and lat data. And that is because the plotting library that we're using uses a orientation of lat long, yx, instead of long lat, xy. And so we have to like reverse those because Earth Engine does it in terms of xy. All right, so I'm going to run that. So we have that location information in a variable. I can echo it back if I want to see to verify that they switch the coordinates around. And then finally, we are going to instantiate a map object. And this, before I click on this, I'm going to go back to show you where that was defined in the Python imports here. We had a line, let me highlight it right here. From this Earth Engine Jupyter package that we installed, there is a module called IPyLeaflet, which has a map class inside of it. So that's the one that we're going to use in order to get this behavior. So if I go back down to where I'm going to run that, it was already displayed there, but I'll run it again. And now we have our map. Let me zoom out a little bit so you can see the whole map itself. There we go. All right, so it's an interactive map. If I click and drag here, you can zoom and pan just like you can do in the code editor. The background I'm using is I really like this kind of design by Stamen Designs of these map tiles, which is a watercolor design. And it's a good background because it doesn't really look like satellite data, so you can always see when you overlay something on top of it. But there's a wide choice of the tiles you can use in the background as well. All right, so we got our map here. Zoom back in a little bit here again. And then the next cell that we have is like, how do you take the DEM image object that we have, pass in some visualization parameters, maximum value, minimum value, give it a label, and add it to the map. So I'm going to click on that. And if you go now and look at that map object, you can click and zoom around. The visualization parameters were 0 to 1,000 meters, so a lot of the western US is above that, so that's why it's white there. But you should get the idea that we have some type of visualization applied to an image, and that is now on our interactive map here. I'm going to go down to one more cell that we have just to show that we can add multiple layers to the same map. And I will click on this map, add layer, and it's going to display the same object but choose some different visualization parameters. So we have a min of 0, maximum of 1,000, and then gray to red for the palette. And if I zoom back up here, nobody's going to be writing home about the great color choice that I had here, but it's just demonstrating, what you can do with this map, and that within the map itself, you have the ability to turn on and off layers just like you would in any kind of GIS type of system. All right, so take any questions to where we got at this point. We also listed a little bit of extra practice if you want to try something with what you've learned up to this point, but we'll probably keep going on. There's some questions on the side.
I just had a question about
Yep.
Colab notebooks generally.
Yep.
So if there was a Google Drive link that you sent to all of us and we were editing it, we could all see those changes and oh, we're all going to screw up this template. But when we clicked on that link, if I made any changes to these cells, am I automatically making a copy of my own, or how does that work?
That's a very good question. You see first a read-only representation of it unless you are an editor, and you are not an editor on that document. So if you try to save, it will say, do you want to make a copy? Okay. So you don't have to worry about it in this case, but if you were an editor on it, then you do have to be in coordination with whoever you are editing. And Kayla and I found this quite a bit when we were developing the notebooks. Sometimes we would get into conflicts because we were both editing it. There is a revision history that can help you kind of reconcile. Where are we in there?
This counts.
Oh, sorry, I haven't actually saved it yet, so it's not going to show me the revision history. If you are co-editing one, there's a way to look at the revision history, and it will do differences so you can see who added something there. But in general, I would only have one person edit the notebook at a time. It leads to a lot less confusion. Also, you need to realize that the programming kernel that is running your code is unique to yourself, even if you are sharing the Colab document with somebody else. So just different considerations that you have to have when you're going with Colab when you're trying to do it for collaborative work. Oh, where did we find the image? Yeah. Okay, so where did we get this ID? That's a very good question. I didn't explain it actually up there.
Click on that.
Oh yeah, I can show where this particular one went in because that will bring us out to the data catalog. But the easiest way right now is to go to the web browser of the Earth Engine data catalog, find an image or asset that you want, and then the ID is right here. The other way to go about that is there is what's known as the stack catalog. So you programmatically can search for what data sets are available. That's a little bit more advanced, but there are all alternatives to that. All right, there was another question over here, if I remember. Is it unique? I would say Earth Engine follows the GeoJSON standard, and Maps, I guess, doesn't. So it's always an argument of people in the mapping community of which way do you do it? To me, logically, XY makes a lot more sense to me. So I prefer it the way Earth Engine does it, but yeah. Another question? Yes. So if multiple people are using the same notebook like we are in this, everybody has to authenticate by themselves. You do authenticate just once for a notebook, but if you went away and Colab has this thing that it recycles the virtual machine behind the scenes, if you leave it alone for too long, when you come back, you would have to start over and re-authenticate with it. If you move to something outside of Colab, one of the other environments, you might be able to authenticate once and save your credentials like on your local drive, and then it would persist. But in a Colab environment, yeah, we try to keep you from having to authenticate very often, but it does happen. All right, one more question or? Oh, okay. How much freedom do we have to install extra Python packages? Python packages. You have the freedom to install them, but if they are graphical, they may not work in Colab. There may be some restrictions of like what it can do in an output cell. So in general, in general, you can try to install it. It has to be a version that is compatible with the other Python libraries that are within Colab. So you might run into some challenges there, depending on what you're trying to install. If you host your own Jupyter environment, you have a lot more flexibility to install what you want. Yep. Okay, at this point, I think we're ready to.
Yeah, so we just displayed an image that showed the elevation. Now let's find out even more about like this data. Like let's explore it further. Let's run a computation on it. So if we have elevation data, I don't know, maybe we can think about it. Like what kind of things could we find out? One natural suggestion would be to find the slope, right? If we have different elevation, we might want to find the slope. So that's what we're going to do, just to show you what it's like to run a computation on an image. So we're going to use the ee.terrain.slope, which basically looks at the neighboring elevation values for the different pixels and calculates the slope. And then we're going to display it on a map. So on this map, I've added the elevation data, the one you already made with or created with Tyler, and then we're going to also add a slope layer. I put the max value for the slope to be 30, just because it's kind of rare to have a slope that's greater than 45 degrees in this area. So then I'm going to run it. And this is what the slope looks like. Pretty cool. And as Tyler said, you can toggle between the layers. So we can see the slope, but what if we wanted to find the slope at a particular point on this map? Well, we're going to use a map inspector. So there's two different ways that we can create a map inspector using the Earth Engine Jupyter library. The first is if you already have a map. So we already created a map up here, like a map object, map 2A, and we want to add an inspector to it. We can create an inspector using this inspector method, and then we can just display that inspector right beside the map using this HBox widget. Basically, the HBox widget just allows you to display things side by side for the output. So right here we have the map and we have the inspector. So I want you to go around somewhere and pick a point. And you can see that you can find like the longitude and the latitude, how zoomed in we are, the scale, and we can also find what we are looking for, the elevation value in meters and the slope. So I showed you if we already had a map and we wanted to add an inspector to it, we'd call that inspector method. But if we didn't already have a map and we just wanted to create a map with an inspector, then we can call this function called map plus right here. So map plus creates a map and adds an inspector to it for you. So this doesn't have any layers on it because I didn't add any layers yet. but you can add the layers to it. And it's the same thing as what we had above here. So they're just two different approaches to adding an inspector to your map. Do we have any questions? Okay. So now let's find out even more information about our image. So we're going to do some image math. We're going to calculate the aspect, which is the orientation of the slope, basically the direction of the slope, measured clockwise in degrees. So 0 degrees is north, 90 is east, 180 is south, and 270 is west. And then for fun, we'll do some more math, and we'll compute the sine of the aspect. So the sine of the aspect is the eastness of the slope, with east being +1 and west being -1. So we want to see what those look like, right? So let's display it side by side. So I'm just going to show you, I showed you already that with the H box that you could put the map and the inspector side by side. Now we're going to put two images side by side. And when we're talking about eastness and westness, Tyler and I picked Mount Shasta. It's a mountain in California because it's pretty cool to look at. Like the mountain face, one of them faces east and one of them faces west, so it's kind of fun to look at. So we made this point around Mount Shasta, and we made a new map object, and we added the elevation to it. And then we made another map object and added the sine of the aspect. And then we can display them side by side. So I don't know about you guys, but the map on the left kind of just reminds me of an iris. But it's not, it's Mount Shasta, I assure you. But yeah, it's pretty cool, right? Like, I think it's cool to see. So here, sorry, I forgot to mention, green is, we defined like what the colors mean. Green is west, east is blue, and white is north and south. So this is like the east side, and this is the west side of the mountain. And we wanted to show you that you can query the map objects we've created. So if you want to find the center of the map, you can just call map, whatever the map object was, in this case, map2b.center. And then I also wanted to show you that, let's say you move over here, but you also want to move the same direction here. Like if you want those maps to be synchronized, then we have a function here that allows you to do that. So now if I move, it follows. All right, any questions now? Okay, we're going to now do some stats. So this is where I would like you guys to participate. What we're going to do is we're going to create a custom geometry on a map, and then we're going to find the mean elevation in that area. So the first step is we're going to create that custom geometry. So we're going to use draw control. So we're going to run this. And basically what it does is it allows you to draw things on a map. So you can click on this pentagon and then draw a shape, whatever you'd like. And then when you're done, you can click finish. So this is our custom geometry that we're going to find the mean elevation in this area, this blue shaded area. Has everyone created their region? So it prints out the region coordinates, and this does it in a nicer way, not as much information. So we have this cell basically to say if you didn't create a geometry, you can run this, but it won't overwrite your geometry that you made. And then now we're going to calculate the stats. So like I said, we're looking for the mean elevation on this geometry. So in order to calculate the stats, we're going to call reduce region. So it looks at the region we created, like this geometry, and it applies a reducer to it. And you could use another reducer here, but right now we're interested in the mean, so that's why we're using the mean. And then we have the scale, which Tyler arbitrarily chose. I don't know how he picked 90, but you put a scale there, and then there's best effort, which basically means if there's too many pixels in your area and it doesn't work with the scale that you chose, just Earth Engine, try your best to still find a value. So my mean elevation was 260 meters. Do we want to pause for questions? Because we have 3 minutes left, rather than talking about a new topic.
Sure. Yep. If there are questions on that, we'll take those and then before we go to the break.
Thank you. Does the scale mean resolution?
I don't know, Tyler does. How do you
You can
define
turn me
scale?
back on. The scale means the resolution that we are sampling the image at. So if the underlying data set in this case, SRTM, I can't remember whether they're using the 30 meter or the 90 meter version of it, but that is basically the pixel spacing there. You can sample at a larger, because we do what's known as pyramiding to basically report the information at a higher scale. And so you can control basically of how finely you are sampling it. Generally, if you're doing something like we are, like sampling points on an image, you want to match the scale to the resolution of the image. And we just took a shortcut doing it this way. We could have programmatically asked the image what its native resolution is. There's something that's called nominal scale in your in the Earth Engine toolbox that you can do that. Scale also comes into play even more importantly when you start doing things, I guess in this case it was for a polygon there. So how finely are you sampling within that polygon region that you're sampling?
The resolution of the resultant. The resolution of the resultant, right?
The resolution that you are calculating the results.
Okay.
In this case, we are reducing down
Got it, yeah.
90 meter pixels, basically, an image of 90 meter pixels. If you make it too crude, you're going to get a very inaccurate result very quickly.
Okay.
So it's a trade-off of like how much computation you want to do, especially when you're looking at really large regions on a very finely detailed image.
Yeah, thank you.
If we increase the scale, then it should be different, right?
It'll be, yeah, if you change the scale in here, it will probably be slightly different. It depends on, you know, how variable the topography is that you're trying to reduce.
It did change by 2 meters.
But that's actually an interesting thing that Python can be very good for, is that you can set up a loop and sample for a variety of scales and answer that question of like, does it make a difference or not? You can see this, you can do what's known as a sensitivity analysis of like varying one parameter to get a bunch of results and then just seeing whether you can get by with a coarser scale. It might be appropriate for your application.
I just wanted to verify I'm understanding what's going on when we draw the polygon. That's locally, and then this command about create an Earth Engine server-side geometry, that's putting it up in an Earth Engine. And you have to do that in order for the reducer to work in the next step, right?
That is correct. You are drawing client-side there, and you do have to instantiate a server-side object in order to get the reducer to calculate it on the server side, yes. Yep.
Thanks for asking.
I have one question. I can see that, is there an easy way to have access to the different functions within the Python package that we just load? For example, I can see that you import from Jupyter IP leaflet the inspector a command. So is there a way to get an overview of what different commands exist and what do they offer? Or do we go to the GitHub and try to get an idea?
If the package has been constructed as it should with the correct documentation strings, then you should be able to type help and the name of the object or the method, and it should give you the appropriate level of details. For the EE Jupiter, I am definitely making no guarantees that that is the case right now. It's something that we will want to do.
I guess
It probably will be better when you do the EE library, the Earth Engine library. If you do help on that, it will give you a lot of details. The other thing that you can do is there's a command in Python called dir, directory structure for the objects, and that will give you the properties, the methods, lots of information about that object.
Because right now we are restricted to the functions that you show in this Jupyter notebook to what we learn. I mean, there might be much more information that we have to explore ourselves.
Yes, there is so much more than we can cover in EE 101. There's over 1,500 different Earth Engine methods at this point on probably a dozen different objects, actually more objects than that.
There's also comprehensive online docs for all 1,500 methods.
I ran it, Tyler.
Yeah. Yeah, our documentation, when you go into the Earth Engine documentation reference client libraries, it will give you a list of the objects. Most of the examples are in JavaScript, but the objects are available in Python as well.
I ran it, but it doesn't really do as
Oh, so she actually ran it on one of the
inspector
map
that you were
objects,
talking about,
and it
yeah.
is giving you too much detail
It
in this
looks a
case.
lot.
It's talking about like everything a widget can do underneath the hood. So that's going to be probably more detail than you want for a geospatial analysis. So.
Yeah, follow up on that. So the method name is similar to what it is in JavaScript, is it? Like ee.images in JavaScript. Like in if RG, it is with the $sign, but the same command name.
Yeah.
So in Python also it's that way?
Generally, we have the same naming convention for the Earth Engine classes and methods, both in JavaScript and in Python. There are some exceptions to that because there are reserved words in each of those languages that we have to avoid. And that is sort of an open question too of like, do we also provide the appropriate like capitalization for the language in addition to making it compatible with JavaScript? Because there's a lot of methods we probably would rename if we were just solely creating a Python library. So we kind of wrestle with this, whether we should do that or not.
Got it, yeah. No, otherwise I was like searching two places, yeah.
Yep.
Thank you.
I think we should take a break now, right?
Yep,
5
so let's
minutes
take
over.
a break. Do we have 10 for?
Yeah, we come back at 2:30.
Yep, so let's take a break for 10 minutes and then we will carry on with the second hour of this.
Thank you.